What is going wrong on Jupiter? That question sounds simple, but it opens the door to one of the most fascinating mysteries in our solar system. Jupiter, the largest planet in our cosmic neighborhood, has always been seen as a giant, stable, and almost unchanging world of swirling storms and endless clouds. Yet recent observations suggest that something unusual is happening deep within its atmosphere and magnetic environment. Something scientists are still struggling to fully understand. For decades, Jupiter was considered a model of stability. This great red spot, a storm larger than Earth, was thought to be permanent. Its bands of clouds were expected to move in predictable patterns. But now, changes are being recorded that challenge those long-held assumptions. The great red spot is shrinking and changing color. New storms are appearing in unexpected places. Even the internal heat distribution seems to be shifting in ways that do not match earlier models. One of the biggest puzzles comes from Jupiter's atmosphere itself. Instead of smooth and predictable circulation, scientists are seeing violent disruptions. Massive lightning storms are forming more frequently. Cloud layers are behaving differently, rising and sinking in unusual patterns. These shifts suggest that something beneath the visible atmosphere may be influencing the planet's weather in ways we do not yet understand. Another mystery lies in Jupiter's powerful magnetic field. It is the strongest of any planet in our solar system, yet it is also showing irregular variations. Space missions have detected unexpected fluctuations in radiation belts and magnetic waves. These changes hint that the planet's deep interior, possibly its metallic hydrogen core, is not as stable as once believed. Even Jupiter's moons are indirectly affected. Subtle gravitational interactions appear to be shifting slightly, raising questions about whether the planet's internal mass distribution is changing. If true, it could rewrite. Jupiter is showing unexpected changes in its atmosphere and overall behavior, challenging the idea that it is a stable planet. Jupiter has long been considered one of the most stable and predictable giants in our solar system, but recent observations are challenging that belief in surprising ways. Scientists are now detecting changes in its atmosphere that do not match earlier expectations. The most famous feature, the Great Red Spot, is not only shrinking but also shifting in color and intensity, suggesting that the storm may be weakening or transforming into something entirely different. At the same time, new and powerful storms are appearing in regions where they were rarely seen before, indicating a possible shift in global atmospheric circulation. Jupiter's cloud bands, which once moved in relatively consistent patterns, are now showing signs of disruption, with irregular movement and unexpected turbulence. Lightning activity has also increased in some regions, pointing to stronger and more chaotic weather systems developing deep within the planet's atmosphere. These changes raise important questions about what is happening beneath the visible cloud layers. Some scientists believe internal heat distribution or deep atmospheric currents may be shifting, affecting everything above. Others suggest that long-term cycles, previously unnoticed due to limited observation time, could be responsible. Whatever the cause, Jupiter is clearly not as unchanging as once believed. Instead, it appears to be a dynamic and evolving world where even giant storms and planetary systems can transform over time, reminding us how much we still have to learn about the gas giant. The Great Red Spot is shrinking and changing, and new storms are appearing in unusual regions. Another major mystery surrounding Jupiter comes from its deep internal structure and the powerful forces operating beneath its thick cloud layers. Unlike rocky planets, Jupiter is made mostly of hydrogen and helium, and under extreme pressure, hydrogen becomes a metallic liquid that conducts electricity and helps generate the planet's enormous magnetic field. Recently, however, scientists have observed irregular fluctuations in this magnetic field that do not fully match existing models. These variations suggest that something unusual may be happening deep inside the planet, possibly involving shifting flows of metallic hydrogen or changes in the internal heat distribution. Spacecraft measurements have also detected unexpected patterns in radiation belts surrounding Jupiter, showing that charged particles are behaving in less predictable ways than before. This raises concerns that the planet's internal dynamics might be more complex and unstable than previously thought. Some researchers believe that deep convection currents could be changing, while others think long-term internal cycles may be responsible for the shifting magnetic behavior. These processes are difficult to observe directly, making Jupiter one of the most challenging planets to study. Every new mission provides more data, but instead of solving the mystery, it often adds new layers of questions. As a result, Jupiter is now seen not just as a giant gas planet, but as a constantly evolving system whose hidden interior still holds secrets waiting to be uncovered by future exploration. Atmospheric activity has become more violent and unpredictable, including stronger lightning storms and shifting cloud patterns. Jupiter's magnetosphere is another area where unusual activity is raising serious scientific curiosity. This vast magnetic environment, which extends millions of kilometers into space, is normally shaped by the planet's rapid rotation and its internal metallic hydrogen layer. However, recent readings suggest that the structure of this magnetosphere is not as uniform as previously thought. Space probes have detected shifting auroras near Jupiter's poles that change intensity in unpredictable cycles, sometimes becoming extremely bright and then fading without a clear pattern. These auroral disturbances indicate that charged particles are interacting with the magnetic field in ways that are not yet fully understood. In addition, radiation levels in certain zones around the planet have shown sudden spikes, suggesting that energetic particles are being accelerated or redirected by unknown processes. Scientists are trying to determine whether these changes are caused by variations in the solar wind, internal magnetic shifts, or deeper changes within Jupiter's core dynamics. Another intriguing possibility is that interactions with its volcanic moon Io are playing a stronger role than expected, injecting material into the magnetosphere and disturbing its balance. Whatever the cause, these irregularities point to a system that is far more dynamic than earlier models predicted. Jupiter's magnetic environment, once considered stable and well-mapped, now appears to be a living, changing structure full of hidden complexity and unanswered questions that continue to challenge modern planetary science. Jupiter's magnetic field is fluctuating, suggesting possible changes in its deep internal structure, including the metallic hydrogen layer. Beyond its atmosphere and magnetic field, Jupiter's internal energy flow is also becoming a major focus of scientific mystery. The planet emits more heat than it receives from the sun, which has always suggested strong internal processes driving this excess energy. However, newer measurements indicate that the way this heat is escaping may not be consistent across the planet. Some regions appear to release energy more rapidly than expected, while others seem unusually calm, creating an uneven thermal map that does not fit earlier models of uniform convection. This imbalance suggests that deep within Jupiter, heat may be moving in complex and shifting pathways rather than rising smoothly from a stable interior. One possible explanation is that layers within the planet are mixing in ways that disrupt normal circulation, possibly influenced by pressure variations or changing material properties under extreme conditions. Another possibility is that long-term oscillations inside the planet are redistributing energy over time, creating temporary hotspots and cooler regions. These irregular heat patterns could also be linked to the strange behavior observed in Jupiter's storms and cloud systems, as atmospheric activity is often powered by internal energy flow. As scientists gather more infrared and microwave data, they continue to refine their understanding, but the results often raise new questions. Jupiter's internal engine, once thought to be steady and predictable, now appears to be far more complex and variable than previously imagined.